Hey guys, so today we are going to start chapter 14, which is Trig, Identities, and Equations. This is the last chapter that we're going to get through for the school year. Depending on timing, we'll probably only be able to have a quiz for this chapter. This chapter is complicated, just so you know in advance. It is a little bit trickier, so maybe now that you're a little happier that we might not be able to have a test. But just so you know, for timing, this is the last chapter that we're going to go over for this school year. And section 1 is trigonometric identities. And our objective for this section is to verify trig identities. So looking at our first equation, we have x squared equals 5x minus 6. That equation, we know there are certain x values that we can plug in that will make that equation true. On the other hand, if we look at x to the fifth over x squared, that simplifies to x cubed. We can plug in any value for x to this term and have a solution. The only number that we cannot plug in is 0 because that will make the left side of that equation undefined. An essential understanding for this section, there are interrelationships among the 6 basic trigonometric functions and that make it possible to write trig expressions in various equivalent forms, some of which can be significantly easier to work with than others in mathematical applications. So some trig identities are definitions or follow immediately from definitions, and you'll see that on the last slide. But we can kind of change up our trig identities in order to simplify. So looking at our basic identities, we know the reciprocal identities. We have cosecant is equal to 1 over sine of theta, sine is equal to 1 over cosecant of theta, secant is equal to 1 over cosine of theta, cosine is equal to 1 over secant of theta, tan is equal to 1 over cotangent of theta, and cotangent is equal 1 over tangent of theta. So those are all of our reciprocal identities. They're going to be very important when we start to try to verify identities. And also the tangent identity can also be written as sine of theta over cosine of theta. So we know from the last chapter when we're talking about tangent, we are writing it as y over x. Well, our y value represents sine and our x value represents cosine. So tangent can also be written as sine of theta over cosine of theta. Similarly, for the cotangent identity, we can write it as cosine over sine because it's a reciprocal. It's just x over y. X represents cosine and y represents sine. So sometimes you're going to need to write cotangent as cosine over sine. Sometimes you're going to need to write tangent as sine over cosine. So you can use known identities to verify other identities. And to verify a trig identity, you can use previously known identities to transform one side of the equation to look like the other side. So this is very important. We're only transforming one side of our equation. Otherwise, it's going to make the problem much more complicated and you're going to have to do a lot more work. So we're transforming one side of the equation, and normally when we're doing this, we're going to pick the more difficult looking side of our equation to simplify in order to verify an identity. So let's try a few examples for verifying an identity using basic identities. Now, our first example for verifying using identities. So we have verify the identity, and before we start, we're going to try and figure out which side we need to simplify. So remember, I said earlier that you want to choose the more complicated side of your equation to try and simplify. So we have sine of theta times secant of theta equals to tangent of theta. So you can see the left side we have two terms. So that's the more complicated side. So that's what we're going to try to simplify. And the right side, tangent of theta, we're not going to do anything to that side. It's going to stay the exact same all the way through this problem. So the first thing you want to do, I think it's a little bit easier if we set up a goal that we want to get to with the left side. So our goal here to verify this identity is that it's going to be equal to tangent of theta. But if you think about tangent of theta, that's also equal to sine of theta over cosine of theta. So that's what we need to get the left side of our equation to look like in order to verify. So we have sine of theta times secant of theta. When you have multiplication, it's usually easier to try and split up your two terms. So I'm going to keep sine of theta the same. And secant of theta, I want to try and get this term into sine and cosine terms. So secant of theta is really equal to 1 over cosine of theta. And the right side is staying exactly the same. I'm going to ignore it for now. Sine of theta times 1 over cosine of theta. If we multiply, then we have sine of theta over cosine of theta. And notice that this looks exactly like the goal we're trying to get to. Sine theta divided by cosine of theta is equal to tangent of theta, which equals the right side, which is tangent of theta. So when you're verifying, you are not finished until the right and the left side of your equations look exactly the same. So in this problem, for example, we can't stop once we get to this goal. You can't stop at sine theta divided by cosine of theta. You have to simplify it to tangent of theta so that everything looks exactly the same. So let's look at another example. For this one, we have verified the identity cosecant of theta divided by secant of theta equals cotangent of theta. So remember, when we start to verify, we need to figure out which side of our equation we're going to work with, and it's going to be the more difficult side. So we have cosecant of theta divided by secant of theta equals cotangent of theta. Again, the left side looks more complicated, so that's what we're going to try and simplify. The right side is going to stay exactly the same. We're not doing anything to that right side throughout this problem. Next, we're going to set our goal. So our goal is to get to cotangent of theta, which is also equal to cosine of theta over sine of theta. So here we have, on the left side, we have cosecant of theta divided by secant of theta. So I'm going to split those two terms up to be cosecant of theta times 1 over secant of theta. Cosecant of theta now is equal to 1 over sine of theta. And 1 over secant, remember if we're talking about reciprocal, 1 over secant is equal to cosine. So multiplying by cosine of theta. If I multiply these two terms together, I have cosine of theta over sine of theta. Now you'll notice this is matched up with our goal that we set at the beginning, so we only have one more step to simplify. Cosine of theta over sine of theta simplifies to cotangent of theta, which is equal to our right side, which is cotangent of theta. Once the left and the right side are exactly the same, we have verified that these identities are equal. You can also use the unit circle and Pythagorean theorem to verify another identity. The circle with its center at origin with a radius of 1 is called the unit circle, and it has the equation x squared plus y squared equals 1. So if we look at our unit circle, this equation is basically just using the Pythagorean theorem. We have in our unit circle, we create a right triangle. So here's our right triangle. The radius is 1, so the hypotenuse of this triangle is 1. If we take the legs of this triangle, x squared plus y squared, that's going to equal the hypotenuse squared, which is 1 squared, which is just equal to 1. So we can use this equation when we're talking about the unit circle. So every angle theta determines a unique point on the unit circle with x and y coordinates. So remember, this is very important. Your x and your y represent, x represents cosine of theta and y represents sine of theta. Therefore, for every angle of theta, so if we think about the equation we just looked at, x squared plus y squared equals 1, and we know in our unit circle that cosine represents x and sine represents y. Therefore, for every angle theta, we can write the equation as cosine theta squared plus sine of theta squared equals 1. So all we did here in this equation was replace x with cosine of theta and y with sine of theta. This equation we can simplify now. This part is also very important. This equation can be simplified to cosine squared theta plus sine squared of theta equals 1. And this form allows you to write the identity without using parentheses. So it's very important. This equation that I have underlined here is not incorrect, but it is easier and more simplified to write it as cosine squared theta plus sine squared of theta, because you need the parentheses with this equation that I boxed here in blue. Because if we write it without the parentheses, if we have cosine of theta squared, this equation, it looks like you're only squaring your theta, which is not what we're doing. We're squaring everything. So to write it without parentheses, you have to write it as cosine squared theta plus sine squared theta equals 1. So it is very important when you're writing this equation that you have to write the power in between your trig identity and theta. That's how you have to write it. And this is actually one of our Pythagorean identities. Our other Pythagorean identities, so we have cosine squared theta plus sine squared theta equals 1, 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. So these three Pythagorean identities, it's very important that you have to know. It's your responsibility to remember them. And another important thing that we have to talk about is that these identities, we can change them a little bit by doing one step in each equation. For example, for our first one, we have cosine squared theta plus sine squared theta equals 1. We can also write this as sine squared theta equals 1 minus cosine squared of theta. So we can change these Pythagorean identities just by doing one step, but you don't want to keep moving terms back and forth. It doesn't work like that. Pythagorean identities, you only have to do one step. So you can change these by one step. Another way we can change our first equation, we can say that cosine squared of theta is equal to 1 minus sine squared of theta. So these are all good because it's just one step. So these Pythagorean identities, we're just changing it by moving one term. For example, for our second, 1 plus tan squared of theta equals secant squared of theta, we can say that tangent squared of theta equals secant squared of theta minus 1. So we can change these just by moving one term. And these Pythagorean identities are going to be very important when we continue to try to verify identities. And remember, when we're verifying identities, there are more than one ways to do it. There are different methods. It is kind of like a guess and check in a way, trial and error. You're going to have to try a couple times before you really get used to figuring it out. So don't get frustrated. It's going to take a lot of practice, but we're going to do a couple of examples so you get a good idea of how to do it here, and then it's going to take a lot of practice on your own to really get used to it. So these are the three key Pythagorean identities that you're responsible to remember. The rest you can figure out as you go along. The little one-step changes are a little bit easier to figure out from those three identities. So let's look at this example. Prove 1 plus tangent squared of theta is equal to secant squared of theta. So this is one of our Pythagorean identities, but just for more practice, we're going to prove that these are equal to each other. We're going to verify these identities. So the steps are the same. First, we're going to look at this and decide which side we want to simplify. Remember, we want to look at the more difficult side normally to simplify. So our left side has two terms, and our right side only has one term. So we're going to try to simplify our left side in order to verify that it's equal to secant squared of theta. Now we're going to set up our goal. And our goal in this case, we have secant squared of theta, that's equal to 1 over cosine squared of theta. And now you'll notice all of our trig identities are squared, so our goal is also going to be squared. So looking at this left side, we have 1 plus tangent squared of theta. We have two terms and we're trying to simplify it into one term. If that happens, you're going to probably have to find a common denominator. So if we rewrite this in the first step, we can rewrite this to 1 plus tangent square of theta. I'm going to write in terms of sine and cosine because my final goal is to get cosine squared of theta. So tangent squared of theta can be written as sine squared of theta over cosine squared of theta. And remember, on these problems, our right side, because that's not the side we're working with, is going to stay exactly the same. So now we have 1 plus sine squared of theta over cosine squared of theta. We want to create a common denominator in order to get only one term. So my 1, I'm going to change to cosine squared of theta over cosine squared of theta. So I haven't changed the value of the term, I've just created a common denominator. So plus sine squared of theta over cosine squared of theta. So now that we have a common denominator, we can combine these terms to cosine squared of theta plus sine squared of theta over cosine squared of theta. So now we only have one term that we're working with. In our numerator, we have cosine squared of theta plus sine squared of theta. Notice that's a Pythagorean identity. We know that that is equal to 1. So we can rewrite this fraction as 1 over cosine squared of theta. This matches up. 1 over cosine squared of theta matches up exactly with the goal that we're trying to get to. So our final step, we can rewrite this as secant squared of theta is equal to secant squared, is equal to secant squared of theta, and now we're finished. We have proven, using our Pythagorean identities, that 1 plus tangent squared of theta is equal to secant squared of theta. So this problem is a good one just so you can see a bunch of steps. Again, it is a little bit tricky. You might have to use some trial and error, but notice for this one it's very important. If you have two terms and you're trying to turn it into one term, you're most likely going to need to use a common denominator to create that one term. And you know you're finished if your left and your right side of your equation are exactly the same. And there are many trig identities, but most do not have specific names. We just went over some simple ones, which were the Pythagorean identities. So let's look at another example. This one gets a little bit more complicated. So verify the identity. We have secant squared theta minus secant squared of theta times cosine squared of theta equals tangent squared of theta. So again, we're going to start this problem the same way. We want to split our equation in half and look at which side we want to simplify. And again, it's going to be the more complicated side of our equation that we want to simplify. So we have secant squared of theta minus secant squared of theta times cosine squared of theta. So the left side of our equation has two terms, and the right side of our equation just has one term, which is tangent squared of theta. So we're going to try and simplify this left side. The next thing we're going to do is set our goal. So our goal is to get both sides of our equation equal to tangent squared of theta. Tangent squared of theta we know is also equal to sine squared of theta over cosine squared of theta. So we want to get all of our terms in terms of sine and cosine. So again, if we have two terms, we're probably going to need to find a common denominator, but let's look at this left side first and see if there's anything we can simplify. So secant squared of theta can become 1 over cosine squared of theta minus secant squared of theta again is 1 over cosine squared of theta times cosine squared of theta. So notice we have two terms, 1 over cosine squared of theta times cosine squared of theta. I'm not going to cancel anything out yet, though, because I still want to try and get that common denominator. So if we simplify, we have 1 over cosine squared of theta minus cosine squared of theta over cosine squared of theta. So I just multiplied these two terms together, and I created my common denominator. So now I can subtract so that I get one term. It becomes 1 minus cosine squared of theta over cosine squared of theta when I subtract using my common denominator. And notice 1 minus cosine squared of theta, that's one of our Pythagorean identities. 1 minus cosine squared of theta is equal to sine squared of theta. So we get sine squared of theta over cosine squared of theta, which matches up exactly with our goal. So our last step, we can simplify this to tangent squared of theta, which is equal to the right side, which we did not change at all, which is tangent squared of theta. So you know you're finished verifying when your left and your right side are exactly equal to each other. Again, like I said before, there can be multiple methods to solve these problems, so don't get frustrated if you try a different way and it works. That's fine. There are multiple methods, and I'm going to show you that now by completing this problem again in a different way. So we have the same exact problem. Secant squared of theta minus secant squared of theta times cosine squared of theta equals tangent squared of theta. So we know from the last problem we talked about, we're going to split it down the middle, down our equal sign. We're working with our left side because that has two terms rather than the right side is more simplified. So tangent squared of theta, that's the same as writing sine squared of theta over cosine squared of theta. So now notice another way about going about this. On our left side, we have secant squared of theta minus secant squared of theta times cosine squared of theta. Notice we have secant squared of theta in both of our terms. We can factor out a secant squared of theta out of both of these terms, and we're left with 1 minus cosine squared of theta. Now notice in our parentheses we have 1 minus cosine squared of theta, which is a Pythagorean identity, which simplifies to sine squared of theta. So we have sine squared of theta. Secant squared of theta simplifies to 1 over cosine squared of theta. So we have 1 over cosine squared of theta times sine squared of theta, which simplifies to sine squared of theta over cosine squared of theta. That matches up exactly with our goal. So the last step, we can rewrite this as tangent squared theta is equal to tan squared theta. You know you're done because the left and the right sides match up exactly, and we verify that these two are equal. So this was a good way that you can see there are multiple different ways that you can solve these problems to verify your trig identities. So don't get frustrated. Just make sure that you take your time, you set up a goal, and you're only working with one side of your equation. That's very important. You're only changing one side of your equation to equal the simpler side. So let's look at another problem. We have verified the identity sine of theta times cosine of theta, parentheses, tangent of theta plus cotangent of theta equals 1. So this one looks very complicated, but it's actually not as difficult as you might think. So we're going to split this equation. Obviously, it's easier to see that the left side is going to be the more complicated side, so that's what we're going to simplify. And our goal for this one is clear. Our goal is to get everything equal to 1. So the first thing that we're going to do, we're going to rewrite this. Sine of theta and cosine of theta are going to stay the same. And then in our parentheses, we're going to rewrite tan and cotangent as our fractions. So tangent becomes sine of theta over cosine of theta plus cosine of theta over sine of theta. So right now we have everything split up. We want to get one nice term. So I'm going to distribute sine of theta times cosine of theta to both of these terms. So when I distribute to the top, I have sine of theta times cosine of theta times sine of theta over cosine of theta. So I'm going to rewrite everything out. So now I have sine squared of theta times cosine of theta over cosine of theta. And I know I can simplify. We're going to get to that in a second. Now I distribute to my second term, and I have plus sine of theta cosine squared of theta over sine of theta. Now you'll notice in each of these fractions, we can simplify. So in our first fraction, we can simplify cosine over cosine, and in our second, we can simplify sine over sine, and what we're left with is sine squared of theta plus cosine squared of theta. And what we have here is our Pythagorean identity. Sine squared of theta plus cosine squared of theta is equal to 1. So now we verified 1 is equal to 1. We only finish when our right and our left side are exactly the same. So as I've said before a couple times, these problems are going to take a lot of practice. So I'm going to continue showing you practice. Please do not get frustrated. Take your time. Try and work through it. It might take a couple times for you to go through to really get used to it and figure out which steps you need to take in order to get to your final solution. So for our next example, and bear with me, this one's going to be a long one, but it's good that you can see a bunch of different example problems. So for our next one, we're going to verify the identity of tan squared theta minus sine squared theta equals tan squared theta sine squared theta. So again, we're going to split this equation down the middle, and we're going to look at our sides to figure out which one we want to simplify. So on the left, we have tan squared theta minus sine squared theta. We have two terms here. On the right, we have tan squared theta times sine squared theta, so we only have one term here. We're usually not going to want to transform multiplication into subtraction, so we're going to choose the left side to simplify. We're going to use that subtraction, create a common denominator, and get it into one term. So after we decide which side we're going to work with, then we need to set up our goal. So our goal, we have tan squared theta times sine squared theta, which is also the same as saying sine squared theta over cosine squared theta times sine squared theta. So our second to last step, we should hit our goal. Now let's start to simplify. So we have tan squared theta minus sine squared theta. First thing, we want to get a common denominator, but we're going to simplify a little bit first. So tangent squared of theta can become sine squared theta over cosine squared theta minus sine squared theta. So notice we have sine squared theta over cosine squared theta, which is in our final goal, so we're probably on the right track. Next thing we need to do is get a common denominator. So my term on the right, sine squared theta, I'm going to multiply by cosine squared theta over cosine squared theta to create that common denominator. When we multiply, we get sine squared theta over cosine squared theta minus sine squared theta cosine squared theta over cosine squared theta. So now we've created our common denominator and we're able to merge these into one term. When we do that, we have sine squared theta minus sine squared theta cosine squared theta all over cosine squared of theta. So now we're getting there. We only have one term now. Next thing, looking at our numerator in this problem, we have sine squared theta minus sine squared theta cosine squared theta. Notice what we have in common with these two terms is that both terms have sine squared theta. So we're going to factor that out. When we factor that out, we're left with sine squared theta minus, we have sine squared theta times 1 minus cosine squared theta all over cosine squared of theta. So now you'll notice in our parentheses here, 1 minus cosine squared of theta, we have our Pythagorean identity. 1 minus cosine squared of theta simplifies to sine squared of theta. So I'm going to simplify over to the right. Sorry, we're running out of room here. When we simplify, we're left with sine squared of theta over cosine squared of theta times sine squared of theta. So all I did was separate this fraction, and now this matches up exactly with the goal that we are trying to hit. So now we know we've done everything correctly. So for our final step, which I'll move a little bit down so we can see, our final step, we're going to rewrite the left side as tangent squared theta sine squared theta is equal to tangent squared theta sine squared theta. And that is our final step. Because the left and the right side of our equal signs are exactly the same, we have verified that these identities are equal. And I know this one was a long one. Sorry that I ran out of room at the end, but there is definitely another method to use to solve this one, so don't be afraid. If you see another way to do it, try it out. As long as you get to the same exact spot at the end, you verified your identity and you are good. Now, you can also use trig identities to simplify trig expressions, and this is the last thing that we are going to do in this section. So let's look at an example. Simplify the following expression. And notice now we're only simplifying to see if there's an easier way to write this. We are not verifying anymore. If you're verifying, you will see an equation with an equal sign where you have to choose which side you want to simplify. Here, we're just simplifying one expression to see if we can put it in easier terms. So now we have cosecant theta times tangent of theta. And we're simplifying. I like to put everything in terms of sine and cosine. So cosecant of theta becomes 1 over sine of theta times tangent of theta becomes sine of theta over cosine of theta. Now you'll notice that our sine of theta cancels out, and we're left with 1 over cosine of theta. But we're not done here. We're not going to leave this as 1 over cosine of theta. Just make sure that you simplify fully. 1 over cosine of theta is equal to secant of theta. So cosecant theta tangent of theta fully simplifies to secant of theta. One more example for simplifying. We have simplify the following expression, secant of theta times cotangent of theta. So again, first thing we want to do is put everything in terms of sine and cosine. So secant of theta becomes 1 over cosine of theta, and cotangent is cosine of theta over sine of theta. So notice we are able to cancel out cosine and we're left with 1 over sine of theta. 1 over sine of theta simplifies to cosecant of theta. So secant theta, cotangent theta can be simplified to cosecant of theta. So when you're simplifying, you want to try and get everything in terms of sine and cosine, then cancel out anything that comes up in your numerator and your denominator. When you're multiplying that match up, you can cancel those out right away to make your expression even more simplified. So that's it for this section. Sorry, I know it was a long one, but there's a lot of practice. And the last thing that I want to say for this section is I know it's tricky when you're solving these problems, but make sure that you take everything into account when you're looking at these problems. I like to start by setting a goal. It makes it easier to see what exact point you're trying to reach, and always remember that there may be more than one way to solve these problems. So try not to get frustrated. It might take a lot of practice and trial and error to really get to understand and get better at solving these problems in a timely fashion. So your homework is posted to Google Classroom. As always, if you have any questions, do not hesitate to email me. Good luck.